All right, so I'm going to start going through practice exam A. If it gets a little echoey, I apologize. I'm doing this in an empty room with the dot cams tonight. So the first problem we've got two different groups, Indiana and Ohio. We have their sample means and their sample variances. We're then asked to construct a 99% confidence interval for the true difference between these groups' population means. So because we only have sample variances, if we go to our formula sheet, we'll kind of be reminded, I can find the difference in sample means when I have known population variances, or if I only have sample variances, or the difference in sample proportions. Well, here we've got means and we only have sample variances. So this is going to be the formula we use. We're going to have to look up a t-value, the number of standard deviations away we need to go to the left and right to get our lower and upper bound. That degrees of freedom was that real complicated equation. So I'd have to give you that assumed true degrees of freedom. So once we have that assumed true degrees of freedom of 50, and we know that we want the 99% confidence interval, right? Our alpha value is going to be 0.01, but we want the t-value associated with that degrees of freedom of 50, and then alpha over 2, so 0.01 over 2, or 0.005. Okay. From there, it's just a matter of plugging everything into that equation before we look up that t-value. So we had, if I had the simultaneously pull that formula sheet up, I want to find the difference in my sample means. So here I had what? Group 1 was 27. Group 2 was 29. I'll then go a certain number of standard deviations to the left and the right, and then multiply that by the standard deviation for that difference in my sample means, which the formula she's reminded was just the square root of each group's variance, so 25, over that group's sample size of not 50, 40 here, and then add the other group's sample variance over its sample size, which we had 50 people from Ohio. So the only thing left to do here is go to our student t-distribution. We wanted, what, 0.005 in that each one of those tails. Our degrees of freedom was 50. So 0.005 in the tail, down to my degrees of freedom of 50. So I'd plug in that 2.678. And from there, it's just a matter of getting this entered into our calculator correctly. Okay. So if we do that, let me see, I think my calculator here, but we can use Excel real quick just to be our calculator. So I'm going to put this in. So all we're going to do is take 27 minus 29, subtract 2.678 times the square root of 25 over 40 plus 36 over 50. And I forgot my equal sign. So we had a lower bound of negative 5.1. So from that, hopefully we can identify, sure enough, negative 5.16. If we recreate the upper bound and we add instead of subtract that margin of error, we should get 1.106. Okay. So for number 2, right, if we wanted to find the test statistic for whether or not Indiana has a lower BMI than Ohio, or that this true difference is less than 0, we'll go to our formula sheet. We've got 3 test statistic equations. We've got the difference in sample means with sample variances. Hopefully these test statistic problems are some of the easier ones, right? We're just plugging in our values. So we've got 27 minus 29 divided by the square root of that sample variance from the first group over its sample size plus the sample variance for the second group over its sample size. Now, if we think about this test statistic, it's coming from a student t-distribution. And if we remember that student t-distribution is centered around 0, if I find a negative sample difference, right? Sorry, this should be for my difference variable. Now I've assumed that that true difference is 0. Finding that sample difference of negative 2 should map out onto a test statistic, since this distribution is also centered at 0, that is going to be negative, right? So we plug everything in. I believe, once again, I could use Excel to be my handy calculator here. So I'm just going to go over here, use this to be my calculator, got everything plugged in. So what, 27 minus 29 divided by the square root of 25 over 40 plus 36 over 50. So negative 1.72, negative 1.725. So that should be C there. So those test statistic equations really are just, once we identify the correct equation, just getting our numbers plugged in there correctly. Okay. For the next one, we've got that same assumed true degrees of freedom, but it says instead, just in case you got number 2 wrong, assume that you found the test statistic was negative 1.55. What's the critical value at the 95% confidence level, and what's the rejection decision? Well, if we think about the 95% confidence level here, my alpha would be 0.05. So alpha is 0.05. I've got a left-tailed test, so I want all of that area of 0.05 to be in that lower left tail, which means my critical value will be negative. Okay. So from here, we're going to just look that value up in our standard normal table, or sorry, our student T table, 0.05 at degrees of freedom of 50, 1.676. So here, right, I could find that value, but I have to remember it's a left-tailed test, so it's going to be negative 1.676. Now from there, A should be the correct answer. But even if I had given you some other answers that made a little more sense, how can I determine my rejection decision? Well, if I have a test statistic of negative 1.55, remember, once I have that critical value for a left-tailed test, the rejection region is the area to the left. If I plot that test statistic of negative 1.55, it's not quite in my rejection region, so that's why I failed to reject. Okay, and I knew it was negative because it was a left-tailed test. We're dealing with that left side of that student T distribution. All right.